Hello everyone, this is Professor Chan for Math 1245. Today we are going to be going over the last part of section 2.2, which deals with piecewise functions. Now let's talk about what piecewise functions are. In your book it can be kind of long and convoluted, but I want to explain kind of the general gist of it. We're going to practice doing graphing piecewise functions, but then first we're going to talk about evaluating piecewise. So I'm going to show you an example like this right here. So when I'm looking at piecewise function, there's something I've noticed here, right? Piecewise is a following where essentially I have two different types of functions, or essentially two different types of graphs based on a specific boundary, right? So if you notice here, my top one is 4x minus 1 only when x is between negative 4 and 5. But once x is between 5 to 6, right, it changes to x squared minus 25. So based on the boundaries I have, it changes to a different function or a different part of a function each time. So let's talk about evaluating functions. So when I'm doing a function, let's take a look at let's say I'm doing part B right here. When I am evaluating a function, I'm still going to do the same thing, right? F of 1 is, remember, back in our very first clip, is when x is equal to 1, what is y? So now the thing is, I have to be very careful of my domains or my boundaries. So I notice 1 is between negative 4 to 5, so I use the very top one. So I'll do f of 1 is equal to 4 times 1 minus 1. And this is equal to 4 minus 1, and that equals 3. And that's pretty straightforward. Now, if I do part D, it's a little bit different. So part D says I need to find f of 6. Now, when I'm doing f of 6, I now notice that 6 falls under the second one, right? Because the second one only contains from everything between 5 to 6, excluding 5. So I'm going to plug this into the x squared minus 25, and I do parentheses 6 squared minus 25, and that will be 36 minus 25, and that equals 11. Okay, so you can kind of see the difference between B and D based on the parameters or the boundaries that the x value falls in. Okay, I just want to quickly show you part C, because one thing you need to be very careful is your inequalities, the less than or equal to or greater than equal to, right? So less than, right, means you don't include it, but if it's less than or equal to or greater than equal to, you do include it. So if I look at f of 5, I have to be really mindful. I am not actually doing the second one because x only works when it's greater than 5, and it doesn't include 5 here. So here, this is going to be 4 times 5 minus 1, and that will be 19. Okay? So when I find the x-intercepts, right, this is, remember, saying when y is equal to 0. Okay? So this is what I'm going to do right here. So I'm actually going to set both of them equal to 0. So I'm going to set 4x minus 1 is equal to 0. And I have 4x is equal to 1. And divide both sides by 4. And I have x is equal to 1/4. Okay? And then I'll also set x squared minus 25 is equal to 0. So this one, let's just remember, when you solve this, you can factor this. This is x plus 5, x minus 5. And this becomes x equals negative 5. And this becomes x equals 5. Now let's talk about this for the following. We have to be really careful about the situation at hand. X squared minus 25, if we look up here, only works if it's between 5, or sorry, greater than 5, and less than or equal to 6. So if you notice, both of these right here actually do not work. So what will happen is these actually don't exist. So the only x-intercept I have is 1/4, 0. 1/4 does work because 1/4 for this equation does fall between -4 and 5, so we're okay right there. So finding your intercepts and then evaluate your functions is essentially the same type of situation. You just have to be very careful of your domain and your restricted boundaries for the following. Okay, so we're going to move on to our parent graphs and how to graph them. Okay, so we're going to learn how to graph our piecewise. Now, before we graph our piecewise, okay, one thing we want to talk about is we want to remember what's called our parent graphs, okay? And some of you guys may already kind of know how to do this, and this is actually in your textbook, but if you guys don't remember, take a quick look at your parent functions, okay? So these 8 types of graphs are called your parent function. So if I have f of x equals to a number, it's a constant line. If it's x, it's a linear line. If it's absolute value of x, it's going to look like a v. A quadratic will be a u. Square root will look like kind of a curve. Cubics, cube root, and a reciprocal. Those are the 8 ones you need to know. Okay. So the thing is, you just want to make sure you understand the general shape of these graphs. This is what's going to help you. Okay. So what I'm going to do here is, actually, I'm going to just make a new page right here. One of the things that I want to take a look at is the following, okay? So let me I'm going to insert a new page. For the following, okay? So let's just kind of understand the concept of piecewise. So let's say you have a parabola, okay? Sorry, that was pretty bad. Okay. And what this piecewise does is that essentially you are doing a really bad Photoshop or really bad kind of cropping. So example, like let's say you're taking a picture and you kind of cropped it out and you only take a picture of this part here, right? So obviously your parabola will look like this. Or maybe you took a really bad picture and it looks like this. Okay. So the idea is piecewise literally means when we're restricting our domain, we're literally just taking pieces of what we have. The thing we have to be mindful about is, remember, this is just a crop shot, right? Or a specified shot, but is not a photo editor, right? So idea is I will not have, like, whatever pieces I take, it should not look like something like this little squiggle, right? Because this squiggle doesn't exist in my parabola. So that's something I have to keep in mind, okay? So when I'm doing piecewise functions, right, it's going to be parts of my original parent graph. So keep that in mind. The second thing you want to realize is the following, is that remember that this is a function. So that means your graph must pass the vertical line test. Okay, remember that's from the very beginning. That's the very first first video of our lesson, right? Piece of function is going to be can pass a vertical line test. That means if I draw a vertical line, it only goes through one point. So I'm going to do a couple of examples for you on how to graph piecewise functions. So let's talk about this right here. Okay. So what I'm going to do is, if you notice your piecewise functions, right? So I have absolute value of x if -3 less than or equal to x less than 1, and then cube root of x if x is greater than 1, okay? Now, in your homework, they will just ask you to do probably like a multiple choice, or they'll be like, pick which graph is right. But when you are doing your midterm, you must know how to draw this by hand, okay? I want to emphasize this to you guys, okay? You need to learn how to do this by hand. So you probably need to practice doing this outside of class and kind of sketching it to match for the following here. So the first thing what I'm going to do is I'm going to look at each one separately. So I'm going to look at my absolute value of x, okay, for the following here. And I'm going to look at specific points. Now, the one that you want to make sure you realize is you want to make sure you include what's called your endpoint. So that is actually where kind of your graph ends. So I must include -3 and I must include 1. Okay? So I have the following here, right? So if I plug -3 in absolute value of x, right? -3, absolute of -3 is going to be 3. If I plug in 1 for x, 1 for absolute value of x, absolute value of 1 is 1, okay? Now let's talk about what happens when I graph these points. These are at my edge, okay? These are kind of at the ends, right? These are my ends of my particular graph for absolute value. If it is less than or greater than or equal to, less than or equal to and greater than or equal to, you will draw a closed circle. If your inequality is just less than or greater than, you will draw an open circle. Okay? So -3, 3, 1, 2, 3, 1, 2, 3. Okay, this is my closed circle. And then 1, 1, this is going to be my open circle. Okay? And then let's graph some of the other ones. Okay? I want to graph enough points so I can kind of understand what's happening. Some of you guys may kind of be asking me, like, how many points will you need? Okay? And it just kind of depends. It has to kind of look like part of that parent graph. So the idea is, right, absolute value of x, remember, looks like a V shape. My cropped photo, right, of my piecewise graph of this absolute value should resemble part of a V. So look at what happens when I graph this. So I have -2, 2, I have -1, 1, 0, 0, 1, 1, and it looks like this. Okay, everyone see that? So that is actually like part of a V. Everyone see it? It's kind of cropped, okay? But at least it's realistic. You want to see if it looks like it's part of your original graph. Okay, so that's how I graph the first part. I'm going to use a different color to graph cube root. I'll do yellow, or let's do orange. Okay, so cube root of x. Now the one I care about is 1. Why is that? Because that is on my edge. Okay, so I always include my endpoints. Okay, so cube root of 1, if I put that in my calculator, is 1. Okay, and I'll do a couple more. Actually, the only one that works will be 8. Cube root of 8 is 2. So I have 1, 1. This is going to be an a closed circle. Oh, sorry. This will be a open circle. My bad. Okay, and it'll look like this. And I have 8, 2, 2, 3, 4, 5, 6, 7, 8. And it'll look like this. And this will be my piecewise function, okay? The orange one should look a bit more curved, but it's a little bit, looks a little bit like a line just because it's going up very slowly, but it's kind of a slight curve. But that is it. And that's how I graph a piecewise function. Okay. So let's look at one more example. Or maybe we should just do 2. Let's do another example like the following here. So I'm also going to do the following. I'm going to graph each one separately. I'm going to do x squared. First, let's remember what x squared looks like. So x squared looks like a parabola, right? I'm kind of just drawing it off the side so I can kind of visualize what's happening. Remember, it's either going to be a parabola or kind of part of a parabola. Okay, and the thing I realized, it is less than 0. So 0 is my largest number. 0 is my largest x value. 0 squared is 0. And I can go down. So I can go down to -1, -2, -3, right? So I have -1, 1, -2, 4, -3, 9. And then 0, 0, right? Sorry, I should probably not underline it because that would confuse you. But 0, 0 is, right, is going to be an open circle, right, because I have less than. So I'm going to draw this. It's going to be 0, 0, negative 1, 1, negative 2, 4, and negative 3, 9. So it looks like this. Okay. As you can see, right, that definitely looks like it's part of a parabola. It's actually half of the parabola. It's the left half, but at least it is part of a parabola, right? Now, if it looks like a line, right, if it looks like a V, right, then obviously we're doing something wrong, okay? Okay, let's look at 2. So when 2, notice I have x and y. I only have one value, which is 2. And when x is 2, it will always be 2. Sorry, when x is 0, my bad. Yeah, sorry, when x is 0, y will always be 2. Okay? This one will be a closed circle. So I go 0, 1, 2. Okay. Finally, let's take a look at our last one, which is 2x plus 1. Okay? And then in my head, before I start, I'm like, what is 2x plus 1? 2x plus 1 should be a line. Okay, later on we'll talk about this. It has positive slope, so it's going to be going upwards. Okay, I'm just kind of visually, like, you don't have to draw that line that I put above. I'm just kind of visualizing in my head what it should look like. Okay, now the other thing to keep in mind, right, is once again, look at your endpoints. Right, the endpoints, and remember when I'm saying endpoints, I'm talking about the x's that's by an inequality of a particular number, right? So I have greater than 0, so x for 0 is an endpoint. So I plug in 0, okay, and I'm really doing this, right? I'm doing 2 times 0 plus 1, right? And if I calculate that out, that's 1, okay? This will be an open circle, hence the greater than sign. Okay, so I'm going to do an open circle like this. Okay. I'm going to plug in a couple more, 1 and 2 and 3. So if I plug 1 in, I have 2 times 1, which is 2. 2 plus 1 is 3. Plug 2 in here. 2 times 2 is 4. 4 plus 1 is 5. 3 times 2 is 6. 6 plus 1 is 7. And these are some additional points. Okay, do the best you can, and it's going to look like a line like this, and this is my piecewise function. Following. One last thing too about this graph is how also, right, we can clearly see, right, if I draw my vertical line test, if I draw a vertical line test, right, it will actually pass because I'm only going through one point, okay? Even at x equals 0, remember, these two holes don't exist, okay? Yeah, so when we draw a hole, let me just kind of remind you, right? The holes don't actually exist on that graph, right? It just means, right, we're just doing that as kind of like a boundary set to kind of show that it's invisible at that point, okay? But technically it doesn't exist, so that's why if I draw a vertical line, right, I'm only technically going through one, because a blue circle and an orange circle, right, technically doesn't really exist at that. So we're only really crossing one, not three. Okay. So let's go to one more. Yeah, let's look at number 5 here. And again, we're going to do the same thing once again. So I'm going to do x squared. Now, take a look at your piecewise, less than 2. So 2 is your largest, and 2 squared is 4. This is an open circle, right? So I'm going to go here, 2, 1, 2, 3, 4. And then I have 1, 0, -1, -2. -2 squares 4, -1 squares 1, 0, 1. Okay. Okay, if you have a hard time following with what I'm doing, right, all I'm doing is I'm just throwing it in my calculator, right? I'm doing parentheses -2 squared, -1 squared, right? I'm just plugging each one in. That's all I'm doing, okay? So I have -1, 1, 0, 0. Sorry, I just realized I messed up. This should be an open circle. Okay, and this one actually will go like this, okay? Be really careful, right? Because it's less than 2, it's going to continuously go to that particular, right? So -3 will be -9. Let me just actually include that there. And it's actually continuously going up as we're going to the left, okay? I'm going to do y is equal to 6. That is just going to be a dot. Let's take a look at this one here. So when x is 2, y is 6. This is closed circle. So that is going to be right here. And then lastly, I'm going to do 10 minus x. And I'm like, well, what is 10 minus x? This is actually a line that's going to go downwards because I have a negative slope. So this one is going to be the following here. I remember I'm also using 2 and I'm also using 6, right? Because these are my endpoints. So plug in 2. 10 minus 2 is 8. That is open circle. Okay. Plug in 6. That's going to be 4. 10 minus 6 is 4. 3, 4, 5, 6. Be right here. And then I have 4. 10 minus 4 is 6. And that will be right here. Be really careful when you connect. Notice I actually do not keep going because it stops at x is less than or equal to 6. So that is my final graph, okay? Once again, so the way is, remember, how do you know you're correct? Look at each of your pieces. One, they should not conflict with each other. Otherwise, they would fail the vertical line test. So if you notice, once the blue one ends, the orange starts. Once the orange one ends, the red one starts, okay? So you cannot have two of the different colors existing at the same time, right? Otherwise, you're violating what's called the vertical line test, and then it's not considered a function, right? Remember, it's called piecewise functions, right? Emphasis on functions, okay? So that's the first rule, right? Make sure it's a function. Second rule is make sure your graphs, each piece looks like part of your parent graph, right? So if you notice, the blue one looks like it's part of a parabola. The red one looks like it's part of a line. The orange one is technically a horizontal line, but obviously since we're only picking 1 point, it's kind of hard to determine. But idea is that each one is a piece of a parent graph, right? And it should look remotely like that, okay? So you want to make sure you remember your parent graphs, which is what we have up here, okay? It looks like it's either the whole thing or part of whatever that parent graph is, okay? And just sorry if I scroll down, but yes, if you have cube root of x, it should look like this, okay? X cubed looks like this, okay? So make sure you know all 8 of these. We'll have more parent graphs throughout the semester. But you want to make sure you know how to do that, okay? Because that's going to help you picture everything out. If you forget your 8 parent graphs, this is going to make it really difficult for you to do on your midterm. Okay, so other than that, that's pretty much it. Once again, make sure you know how to do this by hand. It's easy to do a multiple choice, but make sure you know how to sketch it as you're doing this, okay? You should probably kind of look at a multiple choice problem like this and then try to actually sketch it yourself, okay? But other than that, I will see you guys later, and we're going to move on to section 2.3.